Welcome to the next installment of this Unreal Engine 5 tutorial series where we create a smart enemy AI system inspired by the Xenomorph AI from Alien Isolation. In this week's lesson, because we'll be covering three very distinct topics, I've decided to split them up into three separate videos and release them all together. All three episodes are available to watch now, but just ensure that you follow each lesson in order, as each lesson builds upon changes from the last. As always, if you like the content, please like the video and consider subscribing to the channel. In part 8, we'll be expanding upon our vision system by implementing multiple vision cones into our alien character in the same style as Alien Isolation. In this video, we'll be emulating the approach that the Alien Isolation developers took when implementing sight perception into the alien. Currently, our character has just one vision cone, but in the game, Alien Isolation, the alien actually has three vision cones. One long distance cone with a narrow angle, one medium distance cone with a wider vision angle, and one close distance cone with an angle surrounding its entire body so that the player can't sneak past the alien at a close proximity. Now, before we implement this approach, we'll first discuss a bit of a problem that arises when trying to implement multiple vision cones. So first of all, we'll just go to our content drawer and we will open up our custom AI controller. And if we select our AI perception component, we do have the ability to add in another sight sense if we wanted to. So we could add a third sense config and then select AI sight config again. And you will be able to see this vision cone in the debug information, but for whatever reason, it just simply doesn't seem to update the perception information. So it's essentially useless. We could go ahead and delete that. The alternative is that we can actually add a second AI perception component. If we select our current AI perception component and press F2 to rename, we will rename this AI perception primary. And now we will go to add a new component and type in AI perception, and we will add a new perception component, which we will call AI perception secondary. And just before we implement sight perception into our new AI perception component, we'll go back to our primary one and then expand the information for our sight config. And we'll just make some changes to this. So what we're going to do now is we're going to make this a more longer distance vision cone with a narrower angle. So we'll change our sight radius to a value of 2000. And our lose sight radius we will change to 2500. And our peripheral vision half angle, we will now change this to a value of 15 degrees. So it will now be 15 degrees on either side for a total of 30 degrees field of vision. And since we will also be adding in a close proximity vision cone as well, we no longer really have use for the point of view backward offset or the near clipping radius. So we can go ahead and set these back to a value of 0. Everything else we will leave the same, so we can collapse that and compile and save. Now let's go to our AI perception secondary and let's implement a sense config. So we will add a sense config. This will be of type AI sight config, and we'll expand the information. Now this will be our medium distance vision cone. So we will set a sight radius of 1000. Lose sight radius, we won't need to really worry about. So we'll just set this to a value of 1000 as well. And our peripheral vision half angle, we will change this to a value of 50 degrees for a total value of 100 degrees field of vision. We also need to make sure that we open up detection by affiliation and make sure all of these are selected. And for max age, I will just set a value of 1 second because we won't really be needing the max age value for our secondary vision angle. Now, we do have a bit of a problem now because although we now have two AI perception components, only the primary sight config will show up in our debug information. Unfortunately, the secondary cone will not. Just to demonstrate this, if we go and hit play, and press the apostrophe key, you'll see that only the one vision cone is currently displaying. So this is unfortunately a bit of a limitation with Unreal Engine, but I will show you a bit of a workaround so that we actually can show some debug information for this vision cone. It's a little bit of a hacky implementation, but it does work. We will implement this now before we start handling the sense information from this cone. So let's go to our content drawer, and we're going to add some debug code to our player controller class that we created in the previous video. So we will go up to the Tute Content Blueprints folder, and then in the core folder, we will open up our player controller. And then up the top here, we'll right click and type in debug key apostrophe. This is the same key that we use to display the normal debug information. And what we're going to do is we're going to create a new event dispatcher. So we'll scroll all the way down to the bottom here, create new event dispatcher, and call this toggle debug vision cone. Compile that, and we'll drag this onto the event graph and select call and hook this up to pressed. We'll just highlight this and press C for comment. Toggle debug vision cones. And now we need to create a listener for this event dispatcher, and we will do this in our Aliens AI controller. So we'll go back to our AI controller. I'll just delete this tick node because we don't need that. Our event dispatcher originates from our player controller, so we will first get a reference to our player controller. So we'll right click and get player controller. Then we need to cast this to our custom player controller. So we'll cast to BP underscore alien underscore player controller. Then we'll check to see if we have a valid reference to this player controller class. So we'll drag off and type in is valid, and we need to select the one with the question mark here. And if the reference is valid, we will bind event to toggle debug vision cone. And then from our event delegate, we'll drag off and select event dispatches and then create event. And we will create a matching event and call this toggle debug vision cones. So now we have a custom event that will be bound to our event dispatcher that we created in our player controller class. Now what we need to do is create a function that will draw our debug lines for our secondary and proximity vision cones. So we'll go over to the functions tab and add a new function and call this draw debug vision cones. And the first thing that we're going to create is we're going to right click and draw debug line. Now, as the name suggests, this will draw a debug line into the world, similar to the lines that are drawn for our current vision cone. It has a line start, a line end. We can select the color for the line, the duration that it persists in the world, as well as the thickness if we want to. The line start will be fairly simple. We'll first right click and type in get controlled pawn. And now we need to get the origin point for where the vision cone starts. And there's already a built-in function for that. We'll drag off the return value and type in get actor eyes viewpoint. So this gives us an out location and an out rotation. The out location will be our line start. Now we'll get our line end location in one moment, but before we do that, I'm going to create a blueprint structure that will contain our variables for our vision cone. So I'll go to the content drawer, I'll go to Tute Content, Blueprints, AI, Alien, and in the structs folder, we'll right click and then go to Blueprint and then create a new structure, and we'll call this F underscore secondary vision cone info. We'll double click that. We'll change the variable type to float. We'll call the first variable secondary vision cone angle. And then we'll expand out the defaults here. For value range, we'll set a range between 0 and 180 so that it never goes below 0 degrees or above 180 degrees. And we can also set our slider range to the same values of 0 to 180. Now we'll create a new variable by clicking the Add Variable button. We'll call this variable Secondary Vision Cone Radius. We'll expand the options, and this time we'll set the value range to be a value between 0 and, let's say, 5,000. That should be much more than what we need. And slider range, again, between 0 and 5,000. And then we'll create one more variable of type float, and this one we'll call Proximity Vision Cone Radius. We'll expand out the options, and this time we'll just set the values between 0 and, let's say, 500. And the same for slider range 0 and 500. Then we'll save that. We'll go back to our AI controller class. We will create a new variable, and we'll call this Secondary Vision Cone Info. We will change the variable type to our f_ Secondary Vision Cone Info variable and compile. And once we've compiled, we can now set our default values to what we set in our AI perception component. So the secondary vision cone angle, you'll recall we set that to a value of 50 degrees. Our secondary vision cone radius, we set to a value of 1000. Our proximity vision cone we haven't set up yet, but we will set the proximity vision cone radius to 150 units. So if we happen to make changes to these values in our AI perception component, we also just need to make sure that we update these default values in our secondary vision cone info variable. It is a little bit of a manual process, but the process does work for our needs. So now let's get back to adding in our line endpoint. Now this is going to require a little bit of math, so I'll just get you to follow along with what I'm doing. So the first thing we need to do is we need to get the rotation angle of our line trace. So to do that, we need to combine the current rotation of our actor eye's viewpoint to the rotation of our vision cone angle. So to do that, we can drag off the out rotation and type in combine rotators. And the value that we want to change is the Z value. And we want to feed in a reference to the float variable that we created in our structure. So we'll drag out our structure variable and select Get Secondary Vision Cone Info. We'll drag off this pin and scroll down and select Break. So this gives us access to all three variables that we created in our structure, and we want to use the information from our secondary vision cone angle. To do this, we will drag out of the B input from our combined rotators and select Make Rotator. And we'll select Make Rotator down here. And we just want to update the Z input. So we'll drag our secondary vision cone angle into the Z input, and that will change the rotation of our vision angle. Once we've done that, we can select this node here and select Hide Unconnected Pins and then compile. But we're not quite done just yet. We'll just drag this out a little bit. And the next thing that we need to do is we need to get the forward vector of this rotation. So we'll drag out and type in Get Forward Vector. And to get the correct length of our line, in other words, the vision cone radius, we need to multiply this value. So we'll select multiply, and this will create a multiply by vector node. We actually want to multiply by a float variable. Specifically, we want to use the float value that we created for our secondary vision cone radius. So we'll drag out our structure, select Get, we'll drag off and select Break again. And this time we will use the secondary vision cone radius output and hook that up to the multiply node, and that will automatically convert this from a multiply vector by float. And then finally, with this output, we want to add this to our start location. So we will drag off this output and press the plus button to add. And then we will add our out location to that node. And then the output of this node will be our line end. Hook that up like so. And then, of course, we'll hook up the execution output. Now we'll clean up this code a little bit. Great. So that takes care of one side of our vision debug cone. We also want to create a second line for the other side of our vision cone as well. So to do that, we can simply highlight all of this, Control C to copy, and then Control V to paste, and we'll hook up the execution. Tidy this up a little bit. Now, to get the opposite angle, what we want to do is we want to take the output of our vision cone angle and we want to multiply that by -1. And what this will do is it will just create the angle for the opposite side of our vision cone. So rather than being 50 degrees, this will change the value to -50 degrees. So let's now see this in action. We'll go back to our event graph. And then out of the toggle debug vision cones, we want to drag off this and create a flip-flop node. And from the A output, we will set timer by function name. Now, the set timer by function name can create a looping execution of a particular function that we enter into this space here. So we need to enter in the exact function name. So we will select our draw debug vision cones function. We'll press the F2 key to edit and then just press Control C to copy that name. And then we will Control V inside the function name section here. The time setting refers to the interval at which this function will repeat. We're going to set this value to a very low value of 0.01 seconds. We do want the function to loop, so we'll select that Boolean. And just to be on the safe side, we'll also select the max once per frame Boolean as well. This will make sure that it will only ever fire once per frame if our timer happens to be set for a faster rate than our FPS. So the first time this event fires, we will start our timer. And the second time the event fires, we want to pause the timer. So to do that, we need to promote the return value of our timer to a variable. And we will just call this variable timer, and then we'll drag the timer variable onto the graph again, select get timer, and then we will select pause timer by handle, and we'll hook this up to the B output. So when we press the apostrophe key, we will start the timer for our draw debug vision cones, and when we press the apostrophe key again, it will then pause that timer. So let's see this in action now. We'll compile and save, and we'll go to our level. And I'm just going to move our player start location. So I'll select the player start and move it to behind our alien. Then I'll press the E key to rotate it, and we'll just turn the rotation around to face the alien. And we'll press play. Hit the tab key, press the apostrophe key, and now you'll see two debug lines on either side of where our secondary vision cone is located. But I might actually just change the color of our debug lines. I don't quite like the black color here. So we'll go back to our AI controller, and in the draw debug function, we will select the line color. And I'm just going to set this to a red value. Highlight that hex value, and I will assign that to here as well. Then compile, press play, hit the tab key, apostrophe. But now we need to actually handle the stimulus information for this vision cone. So now we need to implement this secondary AI perception component. So for that, we need to go to our evaluator. So we'll go to Tute Content, Blueprints, AI, Alien, and we will go to our base evaluator first. Open that up. And this time, we need to get a reference to our AI controller again. And now we need to get the get AI perception, and this time we need to get AI perception secondary. Now, we'll only need to be using the on-target perception updated from this secondary component. So we will drag off and type in bind event to, and we want on-target perception updated. We'll hook that up. Then we will drag off the event delegate, select event dispatches, create event. We will create a matching event. And this one we'll call secondary on target perception updated. And then we'll also create an unbinding as well. So we'll highlight both of these, copy, paste, and then unbind event from on target perception updated. And hook that up like so, then compile and save. And now we'll go to our child evaluator. So if we go to the ST evaluators folder and evaluate perception, go to the event graph. And now if we go to override, we have access to the secondary on-target perception updated. So we'll add that to our event graph. Now what we're going to do is that when our player character enters the secondary vision cone, what we're going to do is we're going to set the focus of the primary vision cone. So what that means is that when we set the focus of the primary vision cone, it will then run all the logic from our primary perception updated. So all we really need to do is that when this event fires, we just make sure that the primary vision cone is assigned focus to the player character, which will then handle all our logic, and that's all we need to do really. So to do that, we're going to create a new function. I will go over here, add function, and we'll call this handle secondary vision, enter. Select the input node, and we will add an input variable. We will call this actor, and it will be of type actor object reference. We will add a new input variable, and this will be called stimulus, and this will be of type AI stimulus. Compile. So then when we receive a stimulus, we want to check the class. So we will get sense class for stimulus. We want to check if that is equal to AI sense site. Then we'll create a branch. And we also want to check if the stimulus was successfully sent. So we will drag off the stimulus and select break AI stimulus, expand this out. And from the successfully sensed pin, we will type in and Boolean. And I'll just hold down the control key and move this to the bottom pin and hold the control, and I'll add this pin here and then add this to the branch. Compile, and then I'll select this and hide unconnected pins. So if our sense stimulus is of type AI sense site and it has been successfully sensed, then we will simply get a reference to the AI controller. So under context variables, to the alien AI controller ref. And now we want to set focus. And hook that up to true. And the focus will be our perceived actor. Let's clean this up. So when we compile and save, go back to our event graph, and then we will drag our handle secondary vision function onto the event graph and hook this up like so, actor to actor and stimulus to stimulus. So now when we go back to our level, press play, press the tab key and then the apostrophe key. Now when we enter the secondary site radius, our alien has perceived us. Great, so that's working. And now we'll add in our final vision radius. So we'll go back to our AI controller. We'll add a new AI perception component again. So we'll go AI perception component, and this one we'll call AI perception proximity. And this will be a close distance vision cone with a 360-degree angle. So we'll go over to sensors config, add new sense config, and this will be of type AI site config. Expand this out. For site radius, we will put this down as 150 units. Lose site radius, we'll put as 150 as well. Peripheral vision half angle, we will set to 180. So that means the total field of vision will be 360 degrees. Detection by affiliation, we need to make sure that all of these are selected. And max age, we will just set to 1 second. Compile and save. And now we need to draw a debug for our proximity vision cone as well. So let's go back into our draw debug vision cones function. So now let's also draw a debug circle for our proximity vision area. And this one is going to be really straightforward. We just right click and type in draw debug circle. And the draw debug circle has a center location, a radius, the number of segments, which I'll explain in a moment, a color, a duration, a thickness, and an axis, which I will also explain in one moment as well. But to get the center location, we will right click and type in get controlled pawn. And then same as last time, we will get the function get actor eyes viewpoint. And this will be our center location. For our radius, we will again use our structure variable. So we'll drag that out and select get secondary vision cone info, drag off and break the structure. And we will get our proximity vision cone radius and hook that up to radius. And then we will hide the unconnected pins, then compile. And of course, we'll just hook up the execution like so. Now, if we compile and press play, and then hit the apostrophe key, you'll see that the vision cone is being drawn, but it's at the wrong axis. We want it to go around the character horizontally rather than vertically. So for that, we can just change the axis value. So we'll go back to our function here, and the value that we want to change in here. So we want to make the y-axis 1 on the x, 0 on the y, and 0 on the z. And for our z-axis, we will make this 0 on the x, 1 on the y, and 0 on the z. And we'll also change the line color. I want to use the same color that we use for our primary vision cone debug. So if we select the AI perception primary, expand sensors config, expand the site config, I will select the color, copy the hex value, then select our line color and paste in the hex value like so. Now, you may have also noticed that our circle wasn't really a circle. It was a 12-sided polygon. We can make it look more like a circle by increasing the number of segments from 12 to 24. And then compile and save. And now when we press play, hit the tab key and the apostrophe, it looks more like a circle. It's in the correct axes, and it's also the same green color as our primary vision cone debug. But now we just need to update the sense information from that proximity vision cone. So let's go back to our evaluator base. We'll get another reference to our AI controller. Now we will get AI perception. Scroll all the way down to the bottom, and we want to get AI perception proximity. And same as last time, we will bind event to, and we want on target perception updated. Hook that up like so. Drag off the event delegate, event dispatches, create event, and we will create a matching event. And we'll call this proximity on target perception updated. Compile. And similar to last time, we'll also create an unbinding. Get another, copy these two. Unbind event from on target perception updated. Hook that up like so. Compile and save. So we'll go back to our child evaluator and then click override and then select proximity on target perception updated. And we just need to copy the same function and hook up execution, the actor, and the stimulus. Compile and save. We press play, hit the tab key, press the apostrophe, and now when we enter the proximity radius, our alien has seen us. And this is how we can implement multiple vision cones using the base engine in Unreal Engine 5. The project files for these lessons are available to download from Gumroad completely for free, but if you would like to support the work that I do, please consider making a donation via the Buy Me a Coffee link in the video description, or by adding a monetary amount in the Gumroad link if you choose to download the project files. And a very special thank you to the people who have already supported this channel. Your support means a lot.